Okay, we just used this formula here, right? Let's see that. To find the area of the sector, we took this, which was the degree measure out of 360, times this was the formula for the area, right? Okay, so now we have a problem in Khan Academy, and it says, okay, this is the area, so 25 pi would be replacing this part right here, right? And then 4/3 pi is the radian central angle, 4/3 pi. So that represents this measure in degrees, but it's not given in degrees, it's given in radian measurement. Well, what is the full radian measurement? The full radian measurement is 2 pi. So let's write this out. Instead of writing, I'm just going to slide that a little bit, and instead of writing m over 360, okay, I'm going to write 4/3 pi over 2 pi, right? Times, and instead of writing pi r squared, because that's the formula for the area, we were given the area was 25 pi, so it's going to be times 25 pi. So what's the first thing that's going to happen? These guys are going to cancel. And then really what do we have here? We have 4/3 divided by 2. So I can write that out. 4/3 divided by 2, which is really equal to 4/3 divided by 2 over 1. How do we do that? Well, we inverse and multiply, right? So that's equal to 4/3 times 1 over 2. And then I can reduce here, right? So this turns into 2/3. So 4/3 pi is really equal to 2/3 of a circle. 2/3 of a circle. So that sector is 2/3 of the full. So I would say, what is 2/3 times 25 pi? Well, that's going to be 25 times 2 is 50/3 pi. Now I can put this in my calculator that same way I originally put it in, right? And instead of working it all out by hand, I can put it in like this. Let's zoom in there a little bit. If I do control divide and I put what is on top 4/3 times pi over 2 pi, right, times 25 pi. Okay, and I get 50/3 pi, which is exactly what we had here, 50/3 pi. The pi I've written off to the side, but this means 50 times pi divided by, this means 50 times pi divided by 3, and this is 50 divided by 3 times pi. It's the same thing. Okay, it's the power of commutation, the property of commutation of multiplication, right? The commutation property of multiplication says, doesn't matter, I can do any of these in any order I want. Okay, so it's basically, it's the same answer. Now, notice how we did it. We took the angle measure here, angle measure. See, angle is A-N-G, no, that's angel. Ha! Angle measure on top. In this case, it was given by radians. If it had been given in degrees, I'd be able to do it differently. And on the bottom, I put the total circle measure. Because again, all I'm doing is I'm writing a ratio that represents what part out of the total we're going to take of the total area formula. Let's go back, and I'm going to hit Control Enter, get a numeric decimal understanding here. This is 52.3599, or about 52.36. What do they want us? They want us to give exact answers. So that's okay. That was 50/3. Let me put that in parentheses. So open parentheses, and I'll put 50 divided by 3, close parentheses, times pi. I didn't like that, man. What am I supposed to do? So maybe I could put 50 pi over 3. Let's try that. So we're going to go, we'll put it in like this, 50 times, or 50 pi over 3. There we go. Correct. Okay, here's the next one. Now we have 80 degrees. Well, how are we going to do that one? That one's pretty simple. It's 80 over 360 times the full area. So that one's actually really, really easy. We don't have to get into pi or radians or anything. We just go 80 over 360 times the area, which the area was given as 81 pi. So 81 pi. Enter, and we get 18 pi is our answer. 18 pi. Okay, next one. We have a trickier one here because, again, we're back to radians, and we have some funny fraction here, 96 over 5 pi. Okay, but we're told that it's a central angle of 108 degrees. Ooh, no, this one's even better. Look at this. We're given the angle measure and the sector measure, but we don't, or the sector area, but we don't have the total area. Oh, this is so good. All right, so let's go back here for a minute and let's work this one out on paper. So let me just write down, what do I have here? I have the area of the sector. I'm going to write this down before I flip the screen. The area of the sector equals 96 over 5 pi. And the central angle, I got to read these slower so I don't get myself jumping ahead thinking I understand what they're asking. Okay, let's go back here. The information they gave us was there was an area sector which was 96 over 5 pi, and the central angle was 108 degrees. So what we're just going to remember is that we're still doing the same thing. We're writing, this is the proportion times the area of the circle is equal to the area of the sector, right? So we're going to use this formula here. Let's go again. It is the measure out of 360 times the area of the circle, which would be pi r squared, is equal to the area of the sector. Well, in this case, what's the area of the sector? We have 96 over 5 pi. The area of the circle is the unknown. I'll call that A, big A, times the measure they gave me was 108, so 108 over 360. Well, when I solve this, I just inverse and multiply 360 over 108. These guys are going to cancel, and I multiply this side by 360 over 108. And I could probably reduce that. Sorry, I'm not getting that very much in the screen anymore. I could probably reduce that a little bit, but I don't really want to reduce it by hand. Instead, I'll just use my calculator. Here we go. What is 96 over 5 pi times 360 over 108? And I got 64 pi. So the area of the circle, 64 pi. Okay, that's how those problems, area of circles and sectors, are done. Okay, we'll go ahead and close the task summary there. Let's take a look at circles and arcs. You have to do circles and arcs. So here we go. A circle has a circumference of 10 pi. It has an arc length of 20 over 3 pi. So this right here is 20 over 3 pi, and the full length is 10 pi. So now we need to know what is the measure, the central angle of the arc in radians. Aha, this is really good. So here we go. We have, let me write this down, this information down, and we'll go back and show you how to do it. Central angle, that's the unknown. That's what we're trying to solve for. The circumference is equal to 10 pi, and the arc length equal to 20 over 3 pi. Okay, so now we're going to try and solve here a little bit. Let's go back to my screen and we'll work through this, okay? Now remember the formula. The formula says we take this proportion here, except it's not going to be measured in degrees over 360. It's going to be the measure of the arc length, right, over the circumference. Okay, so now we know that the arc length times the central angle, the measure of that central angle, I'll call that m over 360. I'm sorry, let's try this again. The circumference times the central angle out of 360, now that would be for in degrees, right, is going to be equal to the arc length. But they don't want it in degrees, so we're going to have to convert this to radians, which really isn't a problem. So the circumference times the measure in radians out of 2 pi, there's always 2 pi radians in a circle, got to know that, is equal to my arc length. In this case, my arc length is 20 over 3 pi. My circumference is 10 pi times m over 2 pi. So now we can just solve. First thing I would do is divide by 10 pi. So now I have divided by 10 pi. So let's just write this out. These guys right here are going to cancel. I have m over 2 pi. Ooh, getting hard to see this. M over 2 pi, right, because these guys canceled, is equal to, I have 20 pi, right, 20 times pi over 3 divided by 10 pi over 1, that's over 1, and then I can make that equal to 20 pi over 3 times 1 over 10 pi, right? And then these guys are going to cancel. The pi's cancel and the 10 and the 20, and so we end up with just equal to 2/3. So we have m over 2 pi is equal to 2/3, and we're going to multiply both sides by 2 pi, and I'm going to get 2 times 2 is 4 pi over 3. So that'd be my answer. Let's go back in there and put in 4 pi over 3. Okay? Alright, so now we have another one. Let's see. A circle has a radius of 9. We know the radius of 9. The arc in the circle, okay, has a central angle of 80. What is the length of the arc? Aha! Well, it's 80 out of 360 times the circumference. Okay, let's work through that one. So the radius equals 9, and the central angle equals 80 degrees, and we're wanting to know the length of this arc. So let's go back to what we know about these things. Okay, we know that the circumference is equal to 2 times pi times r. So in this case, the circumference of a circle with a radius of 9, so that circumference is equal to 18 pi. But they want us to figure out exactly how long the arc is, and the arc has a central angle measurement of 80 degrees. So the arc measurement's 80 degrees. So what is the length of that arc? Well, we would take the circumference times it by 80 over 360. And that I would just do by hand. There's no point. I mean, I would not do by hand. I would do it by calculator. So control divide. Oh, no. I'm going to just go 18 pi times 80 over 360. I used to spend a lot of time working on this stuff. I really don't care to spend that much time on it anymore, the algebra. I used to spend a lot of time working through and reducing and all of that. But the reality is, it's just not worth it. It's just not worth it to me. Our answer is 4 pi. So here we go, 4 pi. Okay, let's do another one. Circle has a radius of 8, and this arc has a central angle of 108. So we're going to do this the same exact way. We're Remember, the circumference is going to now be 16 pi, because 2 times pi times the radius is going to be 16 pi times 108 over 360. So just like we did before, we had a radius of 9 and we figured then the circumference was 18 pi. When the radius is 8, the circumference is going to be 16 pi. So we're just going to go 16 pi times, and then it was, I believe, 108 over 360. Was that the angle measure? Yeah, the central angle is 108 over 360. Oops, let's hit escape there, hit enter. So I get 24 pi over 5. 24 pi over 5. See how these are done? Radius of 6. So what does that tell me the length of the circumference is? 2 times pi times r, so 12 pi. Okay, and this is 7/16 pi out of 2 pi. So here we go. We're going to go 12 pi times, control divide. On the top was 7/16 pi. That's the radian measure of that angle. And a full circle has a radian measure of 2 pi. So instead of just using degrees, I'm just putting the radian measure they gave me, dividing by the number of radians in a circle. And I get 21 pi over 8. Uh-oh, what did I do wrong? Oh, it wasn't 7/16, it was 7/6. So I made that mistake there. And I get 7 pi. Oops, big mistake. Sorry, guys. Okay, and it looks like this next, this one, yeah, this one's a little different. So I'll do this one too, okay? And then we got to move on to one more problem type. So in this case, we have the circumference is 10 pi. The arc length is 1/2 pi. And they want to know in degrees. So here we go. We know that the circumference times m over 360 is equal to the arc length. Let's write this out. The circumference times m over 360 is equal to the arc length. In this case, we have the circumference given to us. It's 10 pi. So 10 pi times m over 360 equals the arc length, and that was 1/2 pi. 1/2 pi. So just to save time real quick, I'm going to use my computer algebra system, and I'm going to let it solve for m. So we'll go menu, algebra 1. We're going to put in this full equation here. So we have 10 pi times, I've got to do something first. Before I can do any of that, I've got to delete all my variables. See, I'm going to clear A to Z. I don't want m to mean anything anymore. All right, because I'm going to use m again. So here we go. 10 pi times, control divide, m over 360 equals, control divide, 1/2 pi. Oh, I made a mistake. I wanted to, let me hit shift and arrow. I'll highlight all of that, use my parentheses, go in here and I say solve for m, the comma m, and then I've got to type in the solve command, which is simply SOLVE. Well, let's see if we get an answer. In this case, it's an 18-degree angle. So we can put that in, 18 degrees. So that's how those problems are done. I'm going to close that out. We'll try one more skill here. We just did areas of circles and sectors, circles and arcs, and now radians and arc length. Just do one or two of these real quick. If it shows up, and it doesn't really. All right, we take a ray pointing along the horizontal x-axis in the positive direction and rotate it counterclockwise by 5 radians. So in which quadrant? So we're going to rotate it like this in this direction. Okay, this is a good question. Let's look at how it should, what we mean by that. We have a ray that's pointing this way along the x-axis, and we're going to rotate it this direction. And how far are we going to go? Well, we're going to go 5 radians. 5 radians. Well, remember, this is pi radians, which is 3.14, right? And this is 3 halves pi, so this is pi over 2 radians, right? This would be 0, and if I rotate all the way, I get to 2 pi radians. Well, 2 pi radians is 6.28, and 3 halves pi, I believe that's 4.71 approximately, but let's just do 3 divided by 2. Let's go 3 times pi divided by 2. There's 3 halves pi, and it is less than 5 radians. It is 4.71. So we know we're going to pass 4.71. If we went this far, we would be to half. That's 1.57. And then we got here, we get to 3.14. And we got to here, we 4.71. If we get to there, we go 6.28. So it's not going to come in that far. If we rotated it 5 radians, it would go around to right about there. That would be 5 radians. So our answer would be, this is quadrant 1, 2, 3, and 4. It's going to be in quadrant 4. Alright, both of the circles are centered at P. The drawing is not necessarily to scale. Which other arcs must have the same length as CD? Aha. So the same length. Well, we've got this. You might think, ooh, this is the same length, but it's not. And I'll tell you why. These angles are the same, but remember, the length is proportional to the radius of the circle. The length of the arc is proportional to the radius of the circle. The radius of this circle is 8, and the radius of this circle is only 4. So CD needs to be on the same circle, the same measure, the same angle. It's going to be arc GH. Okay, P is the center of the green arc. Okay, so the measure of P is 3 pi over 5 radians. And the length of the radius is 6. So find the length of the green arc. Well, that's not too bad. We can do that. If we have, better just double check those numbers, 3 pi over 5 radians, 3 pi over 5 radians out of 2 pi total radians, right? And we're going to multiply that by the circumference, which is 2 times pi times the radius, and the radius here is given as 6. So we get, what is that equal to? And I'm definitely going to use my calculator on this little baby. So I'm going to go ahead and put it all in. Control divide, and in the numerator I've got another fraction. I love how we can do that. 3 pi, just put it in so it looks exactly the way we write it up, and I don't have to worry about it. 2 pi. I know that's not a formal representation, but the calculator understands it, so that's good. Times 2 times pi times 6. And I can hit enter. And I get 18 pi over 5. So let's put that in. 18 pi over 5. And that's how that's done. Okay, the green arc shown below is 7/16 of the circle. P is the center of the circle. What is the radian measure of the angle shown? So if this right here, which is the angle shown in green? Oh yeah, this angle right here, right? So it's 7/16 of 2 pi, right? We actually write this question out in English. We say, what is 7/16 of 2 pi? Question mark. Then we translate this. What is the unknown? So we're going to call that x. Is we use equals for because it kind of defines things. So x equals 7/16 times of, we use times in this case, 2 pi. So we're just going to simply put our calculator in, control divide, 7/16 times 2 pi. Oops. We get 7 pi over 8, or 7/8 pi. I hit Control Enter and I got this number, and I didn't want that. I wanted exact. 7 pi over 8. So 7 pi over 8. Okay, that's how that's done. And now we have the same thing. Ooh, this big one. This is 7/8 pi. What is the radian measure of it? If this is 7/8 pi, we're again trying to figure out what is 7/8 of 2 pi. Again, just like we wrote before, but now what is 7/8 of 2 pi? So we're just taking that exact same problem here, and we're just changing it from 7/16 to 7/8. And we get 7/4 pi. So 7 pi over 4. And that's how those are done. Okay, go ahead and get working on these, okay? Lots of work ahead of you.